Good morning, students. Myself, Janish Shah, Assistant Professor at LG Institute of Engineering and Technology. In today's lecture, we will talk about that how can we insertion and deletion operation perform in Doubly Linklist. Okay, so let's begin. The outlines of the today's lecture. The first one is insertion in Doubly Linklist, and next one is deletion in Doubly Linklist. So, the first I would like to say, students, as you know, that linked list is a collection of nodes. Linked list is a collection of nodes where each and every node contains two things. One is data, second one is a pointer. Okay, that is a singly linked list. A singly linked list, what happens? In which the pointer of the last node pointing to null. Okay, if the pointer of the last node pointing to null, then that is known as singly linked list. But if pointer of the last node pointing to first, then it is known as circular linked list. Got it? So here in today's lecture we will see that doubly linked list. So in doubly linked list we have two different pointers. One is left, another is right. So suppose if this is data, then this is a left pointer, this is a right pointer. So your node contains three things. Middle one is the data, this one is the left pointer, this one is a right pointer. So let's check it out. The first is node. In doubly linked list, node has three different things. One is left pointer, then data, and then right pointer. Okay. Next is left pointer. See, this is data, this is left pointer, this is right pointer. The whole terminology is known as node. Okay, students, the left pointer is known as LPTR. Left pointer is known as LPTR, and the right pointer is known as RPTR. So usually we know about the terms like info and link, if you know about it, right? We usually use info and link. Info for that shows the data and link shows the pointer. But in doubly linked list, as we have two different pointers, LPTR and RPTR, that's why I'm going to use LPTR as for the left pointer and RPTR word for the right pointer. The whole terminology is known as node. So see, this is a whole node for the doubly linked list. One is data, left pointer, right pointer. Got it? So instead of link, I use word LPTR and RPTR, where LPTR shows left pointer and RPTR shows right pointer. See. Next, students, suppose this is the doubly linked list. Fine. Then this link is known as LPTR of 10. This link is known as RPTR of 10. See, it's the right pointer of 10. Fine. So right RPTR of 10. Again, this link is known as LPTR of 40. This link is known as RPTR of 440. LPTR for 23, RPTR for 23. Now, tell me one question. One question arises in my mind that, sir, we have already told you that we know in singly linked list the pointer for the last node pointing to null. Fine, pointer for the last node pointing to null. But here, what happens with LPTR of 10 and RPTR of 10? Same as singly linked list. Here, LPTR of 10 pointing to null, okay, and RPTR of 23 pointing to null. Because there is nothing. LPTR of 10 pointing to null, RPTR of 10 pointing to null. Okay, 23 pointing to null. Fine. So, as you know that in singly linked list we have first pointer. Okay, students, why we are using first pointer? First pointer shows the address of the first node of the list. Fine. But here we have two different pointers. One is L, another one is R. So here, first of all, this is known as node, and then see L. L pointer pointing to the leftmost node of the list. Again, I am repeating the sentence. L pointer pointing to the leftmost node of the list, and see left pointer pointing to the leftmost node of the list. That means first node, and R pointing to the rightmost node of the list. That means last. Okay, so what you need to remember in Doubly Linked List, that there is a node. Node contains two different pointers. First, that one is left pointer, another is right pointer, and then in middle of that is a data. So data, left pointer, right pointer. That is a Doubly Linked List node. Fine. The L is a pointer which pointing to the first node of the Doubly Linked List, or we can say leftmost node of the Doubly Linked List. Whether R is a pointer which pointing to the rightmost node of the Doubly Linked List, or we can say last node. Fine. So again, the terminologies are, the link is known as LPTR and RPTR. So here I am not going to use word link, but instead of that I am using LPTR and RPTR. Students, again I am informing you that in any algorithm for linked list, you just need to draw figure for that. Okay, just draw the figure and then assume that what operation we need to perform. Either it is insertion or deletion in middle and whatever the end. Okay. So here there is a understand terminology. Okay. What is do you mean by the LPTR and RPTR? Let's check it out. So node contains two things, left pointer, right pointer, and data. So if this is my linked list, see, this is my linked list. Now tell me, this is the first node. Which pointer pointing over here? L. Okay. So L is here. This is my last node. Which pointer pointing over here? That is R. Got it? So see, this link pointing to null and this link pointing to null. Now, in any algorithm for linked list, I usually told you that we need to assign name, because names are very much important to do any operation in linked list, right? Name means assigning the pointers. Name means assigning the pointers. Okay. So now please tell me, what is the name of this node? Okay. What is the name of this node? First node, L. Why it is L? Because L is pointing to the first node. Okay. Now the next is, what do we mean by the name of the last node? That is R, because R pointing to the last node. Clear? So here L is here, and this is a link. Okay, this link is known as left pointer. This link is known as left pointer, and left pointer is known as LPTR. LPTR. So this is known as LPTR. LPTR of which node? LPTR of which node? L. So we know that LPTR, or left pointer of L pointing to null. Students, this link is known as LPTR of L. You need to write like this: LPTR of L. LPTR of L, that means this link. Clear? Now, next is about this link. What about this link? See, this is the right pointer. This is the right pointer of which node? L node. So it is known as RPTR of L. RPTR of L. So now, if this is L, so what is the name of this node? RPTR of L. What is the name of this node? RPTR of L. Because L pointing over here, so name of this node is L. Which link pointing to this node? This, it is known as RPTR of L. Fine. Okay. So let's go ahead. So students, see, for the last node or R, as we have this link, left link. So left link is known as LPTR. So it's known as LPTR of R, and right link is known as RPTR of R. So here RPTR of R is pointing to null. RPTR of R is pointing to null. So LPTR of L is equal to null. See, LPTR of L is equal to null, and RPTR of R is equal to null. Fine. If doubly linked list empty, then what happened? Okay. If you have remember one thing, that if my singly linked list empty, then what happened? First pointer pointing to null. Okay. If my circular linked list is empty, then what happened? Again, first pointer is there. The first pointer pointing to null. That means linked list is empty. Same like that, students. If my doubly linked list is empty, then L and R both pointer pointing to null. Clear? So L and R both pointer pointing to null. Okay. So let's begin. Now moving forward to the algorithm, which is known as doubly linked list insertion. Doubly linked list insertion. Okay, we are doing it. So in doubly linked list insertion, what we need to do, we just need to insert insertion to be performed to the left of specified node, which with its address given by the pointer variable m. Okay, what do you mean? Okay, so I will show you with example, but let me just explain little bit. Here, students, we have total 4 parameters. See, procedure double insert. Okay, insertion is there. We are not gonna return anything right now. Okay, we are just doing insertion operation only. If you are comparing doubly linked list insertion with singly and circular, and if you one question coming in your mind, sir, why are we just returning the data element as a function in singly linked list insertion and not in doubly linked list insertion? Okay, fine. Because in singly linked list insertion, we have only one pointer, first is over there, and we always consider first or starting of the linked list as first. That's why I'm returning that. Okay. If you don't want to return that in program, again you can. You can. Okay. But for that, some little bit changes are there in programming. Okay. So it is not necessary to return in program. But for algorithm, yes, you have to write same as book, or I have shown over here. Okay, fine. So students, here we are just taking procedure double insert L, R, M, X. So what do you mean by L? L is the leftmost pointer which pointing to the leftmost node of the list. Fine. What do you mean by the R? R is the right pointer which pointing to the rightmost node of the list. What do you mean by X? X is a value which we need to insert inside. And what do you mean by M? So M is the address of the node. Listen it very carefully. M is address of that node. To left of it, we need to insert something. If this is M, so left side of M, we need to insert something. Fine. So L is a pointer for the leftmost node, R is a pointer for the rightmost node, M address of the node. On left side of this node, we are going to insert X. Fine. Okay. So what is the very first step for insertion? If you remember, what is the very first step of the insertion? We need to take out the node from the availability stack, right? For that, we are performing operations like new arrow avail, then avail arrow, link of avail, and then we get the data node. Fine. But here we are not going to use that terminologies in doubly linked list insertion. The rest of things are very much important, students. Okay, insertion procedure is very much important to understand. That's why in algorithm we are just assuming that by writing only one sentence we get the node. So that is new arrow node. So assume that we have already get a new node. See this is my new node, new pointer pointing to node. Okay, whenever you're writing node in the linked list, it assumes like you have data and two different pointers. Fine. So here we have new pointer pointing to over here. Fine. This is the left link known as LPTR of new, right link known as RPTR of new. This is LPTR of new, this is RPTR of new. Got it? Okay. So we have already got the first node, new node for the linked list insertion. So let's begin with other cases. See, this is the node. Okay. Now copy information field. What we need to insert? We need to insert X. So I'm just inserting X like by writing info of new arrow X. Okay. Next, insertion into empty list. Okay, make sure here we are going to consider three different cases in step number 3, step number 4, step number 5. Each and every step are very much important in Doubly Linklist. Okay, you just need to imagine that okay, this is the scenario, then how can I insert or how the insertion can be performed. So the first scenario is that insertion into empty linked list. Students, just imagine if your linked list is empty, then what happens in single linked list? First pointer pointing to null. Okay. Same like that in doubly linked list, if your linked list is empty, then left and right both pointer pointing to null. Okay. But here we are considering with only r pointer. R is equal to null. If some of you ask me, sir, can't I write L is equal to null? Yes, you can. You are right. You can write L is equal to null. Sir, can I write L is equal to null and R is equal to null? Yes, you can also write. But I think there is no much necessity to write both the conditions L and R. If R is equal to null, that means L is also at pointing to null position. If L is pointing to null, it means R is also pointing to the null position, null pointer. Fine. So it is not necessary to write L and R both. That's why I'm just focusing only on one thing, that is R. If R pointer is pointing to null, see. If R pointer is pointing to null, it means L is also at null. So it means my linked list is empty. My linked list is empty. Okay, so before showing you these steps, I just want to show right now the animation for the new node. Okay, see, right now my L and R both are pointing to null. That means my linked list is empty. So whatever the new node I got from the availability stack, that will become my first node, yes or no. Again, I am repeating the same question that right now my linked list is empty. Okay, I am just taking a new node from the availability stack. So that node becomes my first node. Yes or no? Yes, definitely. Fine. So this node is my first node. Fine. Now, if this is my first node, see, this new node is my first node, then left pointer is pointing to null because LPTR of new arrow null. Okay. Now, tell me, this is my first node, this is my last node because only one node is there in the list. So it becomes my first, it becomes my last. It becomes my leftmost node, it becomes my rightmost node. That means left pointer of new node pointing to null, right pointer of new node pointing to null. Fine. See. So that's why I need to write LPTR of new is equal to RPTR of new is equal to null. Sir, LPTR of new means, I already told you, LPTR of new, that means this link. Left pointer of new, right pointer of new, both pointing to null. Got it? So the next is L and R pointing to new. See, now this node becomes my first node, this node becomes my last node, this node becomes my leftmost or rightmost. Both are same. So L and R now pointing to new. So what we need to write? L arrow R arrow new. Both are initialized with. Got it? So insertion is done. But if for the which case? For which case? If my list is empty. Now I'm going to take another case. Step number 4. See, leftmost insertion. Leftmost insertion. See, in leftmost insertion, what we need to do? We just need to insert a node in the leftmost position. That means before L. Before L. Okay. So Just assuming this is the scenario. This is the scenario for the linked list insertion. Okay, fine. This is 10, 40, 23, 53, 4 elements are there. L is pointing to the leftmost pointer, R is pointing to the rightmost pointer. Now, assuming M is equal to L. So, M is pointing toward L. So, why we are just writing M is equal to L? Students, M is what? M is the address of the node. On left side, we need to insert our new node. Okay, fine. See, if this is M, then on left side of the M, I need to insert something. So it means if I want to insert at the leftmost node, it means over this position, then M should be here. Again, if I want to insert at the leftmost position, then M should be here. So the case is like this if M is equal to M. If this is M, then I need to insert over the leftmost position. Now, so in exam, don't need to mug up the link connections. You just need to draw the figure for your help. Okay, so I'm just drawing this figure for my purpose. Okay, I'm just writing the condition if M is equal to L. So I'm just showing M at L, and now I'm just checking that where I need to insert. I just need to insert my new node over here. Okay, this is my new node. See, that is my new node. Okay, so I need to insert new node over here. So how many steps I need to take? Okay, students, remember one thing. Just take your notebook and pen and write down this sentence. Okay, if you want to do any insertion operation in Doubly Linklist, okay, then you first need to align the link of new node to its necessary nodes. Okay, so what do you mean by the necessary nodes? If I want to insert new node over here, then I need to connect new node with this and this node. If I want to new node over here, then I need to connect new node to this node. Same like that, here right now I need to insert new node at the leftmost position. So I need to assign its link to the existing link first. Okay, do not do any operation. Okay, see, so how many operations I need to write, or how many statements I need to write over here? See, the first is, this is LPTR of new. LPTR of new, that should be null, because now this becomes our first node. Okay, so LPTR of new should be null. Okay, so see, LPTR of new should be null. That is our first operation. Next, I need to connect right pointer of new over here. Then I need to connect left pointer of L over here. Okay, so see, I'm writing LPTR of new arrow null. See, now LPTR of new pointing to null. Okay, the next is RPTR of new pointing to L or M. You can write anything. So usually I'm taking M. So RPTR of new arrow M. See, RPTR of new, that means this arrow. Okay, RPTR of new arrow M. Now it pointing to M. Okay, sir, if I want to write L, then what to do? Fine, you can write L, because L and M both are pointing to the same position. Okay, so now according to this statement, now my right pointer pointing to M. Now how many statements are left? See, this link is left still. LPTR of M pointing to null. We need to change it. Okay, so see what I need to write. Okay, LPTR of M. LPTR of M, that means this link should point to over here. Should point over here. So LPTR of M pointing to this node. This node name is new. So I need to write LPTR of M arrow new. See, LPTR of M arrow new. Insertion is done. So after doing this insertion, what happened? Which is my first node? Okay, my first node is new. So I need to move my L pointer to new. So L to new and return. I'm removing L from M and then to new. See, again, see, fine. So L is already set to the new. Fine. So insertion is done. Though I am just moving my L pointer to the new inserted node, It is not necessary to return first pointer. Okay. So L arrow right now pointing to new. Now the next step is step number 5, which is very much important. Please make sure understand with full concentration. Insert in middle. Consider this doubly linked list. Okay, see 10, 40, 23, 42, 53 and 80. Right pointer RPTR of R pointing to null. LPTR of L pointing to null. This is R, L, this is R. So if I want to insert something in the middle, so I'm just assuming this is my M. This is my M. Okay. So where I need to insert, I just need to insert a new node on the left side of M. On the left side of M, that means over here. Okay. In between of 42 and 23. 42 and 23. I need to insert my new node. So just assume my new node over here. Okay. I'm just assuming my new node over here. I didn't set it left one LPTR and right PTR right now. Okay. So what the first step should I need to do? See, this is my node. So what I need to do? First, you should assign link of LPTR and RPTR of new node to its concerned nodes. Fine. So I'm just setting up the LPTR. That means this left link of new node to this node. Okay. And right link of new node to this node. But wait, what is the name of this node? Okay, first check this. Name of this node is M. Name of this node is M. Okay, why? Because M pointing to 42. Okay, so what is the name of 23? Name of 23 should be LPTR of M. LPTR of M, because left pointer of M pointing to 23. Fine. So if this is 42 is known as M, then 23 becomes LPTR of M, 53 becomes RPTR of M. If this is 42, then M becomes 42, then 23 becomes LPTR of M, 53 becomes RPTR of M. So this is M. Then this 23 becomes LPTR of M. So what I need to connect? I need to connect my LPTR of new to LPTR of M. So see, just focus over here on the mouse pointer. Now, this is LPTR of M. This is M. This is LPTR of M. So I'm just pointing my left pointer of new to LPTR of M. See, done. The first connection is done. Okay. Now, second connection. Second connection is assigning the right pointer of new to M. It is very much easy to write RPTR of new arrow M. So here RPTR of new arrow M. Now, what is my next step? See, I'm just removing this link. Okay. So, okay, no, I'm not removing this link. I'm removing this link. Okay. RPTR of LPTR of M. Okay. Okay. See, LPTR of M should pointing to new. LPTR of M pointing to new. So what I need to write? What I need to write? I need to write LPTR of M pointing to new. See, LPTR of M pointing to new. So it goes like this. This link is already deleted, and then come by pointing over here. New. This is LPTR of M. See, this is M, then this link should be LPTR of M of, okay, it pointing to new. Now, students, tell me, what is the name of this link? Make sure, just focus on this link. What is the name of this link? Okay, sir, name of, this is the right link. This is right link. Right link of which node? LPTR of M. Which node? LPTR of M. Wait, you are wrong. This is right link, that means you should write RPTR, it is okay. But now this node is not LPTR of M because LPTR is already cut it down. So what is the name of this node? Now it becomes LPTR of new. See, LPTR of new. Okay. So right link of, see, right link of LPTR of new should point to new. So what I need to write? RPTR of LPTR of new should point to new. Fine. See, LPTR of new, LPTR of new, that means this link, this node, sorry, this node, and RPTR of, that means this link. So RPTR of LPTR of new should point to new. Okay, this link is gone and pointing over here. So the last statement is written. Okay, so such like this we can do the insertion in Doubly Linklist. In my next lecture we'll talk about the Doubly Linklist deletion, but make sure must do practice for this algorithm and Doubly Linklist insertion. Students, if you have any doubt in this lecture, please feel free to ask me. Thank you so much. Keep smiling.